I designed this course for everybody, including people who've never learned any scripting language at all. It's also easy for people who know some scripting languages to get comfortable with Second Life, very easy with this course. The first few videos, including the bulk of this one, cover the basics of script writing and are applicable to almost any language. After that, we get into how to design and create scripts specifically for Second Life. We'll be covering every aspect of the language we can think of in this course. Let's get into it. I log into the grid using Windows and Firestorm, but the things I discuss and the concepts apply to any viewer in any OS. I've just always been more comfortable with Firestorm and Windows, but you may get better performance with another viewer or another OS. You're happy to use that. The clicks I describe may be different on a Mac, for example. In some cases, a better computer can make a big difference in scripts too. The sim you're on can impact things as well. Lights, for example, have a much more visible impact on sims with a dark night sky. Poor performance in a sim can cause scripts to lag and delay. If you've been in Second Life for a while in a busy sim, you know what that's like. Sometimes you can stand there as a cloud for several minutes and the system gets really choppy. It's because the sim is trying to feed your viewer and every other viewer on the sim all the data it needs to show what everything looks like all at the same time. The same performance issues impacting your viewer as it tries to catch up in the sim can impact scripts as well. Hopefully you've been in Second Life for a while and can relate to some of the common things you'll experience on the grid. If you don't understand something or need more clarification as we go, just send an email to the address in the description or comment down below. I'm happy to try and help where I can and happy to make another video if it helps a lot of people understand SL a little bit more. Everything you see and hear in these videos are my experiences and my concepts. I make mistakes sometimes. I'm sure I'll make some in these videos. I'm happy to hear your comments down below if you think I've made one. You should come in with a very basic understanding of how to manipulate things on the grid in Second Life. I'm not talking about being able to build a house in Second Life. I'm talking about being able to create a box and open it. Make sure you're familiar with the edit window. You'll be using that. As long as you know the basics, it'll be much easier for you to understand as we go through some of these things. I encourage you to subscribe as well and hit the notifications bell to be alerted about new videos when I make them. I'll try to make new videos about concepts and things in LSL that interest you. If there's something you want me to cover, let me know in the comments as well. I'll do my best. If you think the video is helpful, click the like button too if you don't mind. For the rest of this video and the next one, I'll be covering some basic scripting concepts that are common to just about every language. This is more intended to give those who've never written code before a basic understanding of how it works. Even if you have written code before, I encourage you to keep watching so you basically understand some of the concepts as I explain them. It may help you later on. If you feel confident, you can skip ahead, but it may help you conceptually to stick around. I definitely don't want you to get overwhelmed by the thought of writing some really cool code. In simplest terms, code is just a set of instructions you're giving a system and telling it to perform. It runs in lines from left to right, from top to bottom, just like pages in a book. In fact, in the old days with some early languages, lines of code were actually numbered 1, 2, 3, 4, 5, etc. Just about anything you can do with code in Second Life, you can do manually as well. You can tell your code to change a block from blue to yellow, for example. You can do this manually in-world from the edit window also. Code is just a way of automating what you could do manually if you really had to. Like you could, in theory, stand at your store 24 hours a day, 7 days a week, and greet every avatar that comes and give them a note card and a landmark and tell them all about the specials. You could do that in theory, but having a script do it makes it much easier for you. Lets you get a little sleep from time to time. Code itself comes in many forms, just like speech. You have to know the language to know what's being said to you, and you have to be able to speak the language to talk back. Just like spoken languages have nouns, verbs, and adjectives, there are also some very common concepts across many code languages. I want to cover some of these concepts for some people who have never written code before in their life. This will make it much easier for you to understand the examples and explanations going forward. If you're still a little confused after watching this immediately, don't worry. It'll be a good reference video for you to go back to and watch in the future if you need to. As I mentioned prior, code is executed one line at a time from top to bottom. It's also executed in what I'm calling blocks or boxes that are designated to perform specific tasks within the overall code base. These boxes or blocks of code are often nested within each other as well, like a Russian doll, and they often reference each other and send messages between each other too. Just like your brain sends a message to your arm, which sends a message to your hand, which sends a message to your finger and tells it to grab the cup. Think about the process of cooking a TV dinner in the microwave. In a general sense, you take it out of the freezer, you unwrap it, you put it in the microwave for 5 minutes, you take it out, and you eat it. If you break this process down in code, it would look something like this. You would have a process to open the freezer door. Within that process, you would have a function that searches through everything in the freezer and finds the TV dinner that you want. You would then have a function that removes the TV dinner from the freezer, a function that puts it on a counter, and finally, a function that closes the freezer door. Next, you'd have a process to prepare the TV dinner for cooking. But that process can vary depending on the TV dinner you're cooking. Sometimes you have to cut a little slit in the top, sometimes you have to expose one of the compartments, sometimes you have to remove everything. So your code is going to evaluate the type of TV dinner you selected, select the proper prep guidance based on that, and then execute those instructions. Next, you need a process that opens the microwave door, puts the TV dinner in, and closes the door. But maybe you need to put a paper towel on top before you close the door. Your code's going to have a check for that too. After you close the door, you're going to tell the microwave how to cook it. There's a lot of functions you can call with the pre-programmed buttons like popcorn or reheat or chicken or fish. There's even one marked frozen. But you're going to bypass all those instructions and just tell the microwave to turn on for 5 minutes and then turn off and sound a bell to alert you. The bell is going to trigger another process that automatically takes the TV dinner out of the microwave and puts it on the table for you. But before you can put it on the table, you need a process to make sure the table is clear. Because if you try and put it on the table and it's full, you're going to spill the TV dinner all over the place. So you had a process that makes sure everything on the table is removed before you put the TV dinner down. You're also going to need a process for the silverware. Maybe you need to put down a knife, fork, spoon. So then you'll have another process that opens the drawer and makes sure you have at least one knife, fork, spoon inside the drawer. When you think about it, you may not need a spoon every time you're not eating soup. But if there's a dessert compartment, you may want a spoon. So you add a process to check for a dessert compartment, and if there is, you include a spoon. And then you also figure out the only time you're ever going to need a knife is when the meal includes rice. So you add another check to make sure every meal that has rice includes a knife. Now you need to figure out what to drink with your dinner, and you need a whole nother set of code just to figure out what that is, because that's going to vary based on what the dinner is. So you write code for that, and the goal ultimately is to try and automate things as much as you need to or want to based on your needs and desires. Of course, there's also the evaluation of whether or not writing code for something like a TV dinner is even really worth it, because you're probably not going to cook a TV dinner every second. But for something like monitoring your storefront 24 hours a day, code works perfectly. Because even if you can't be there 24 hours a day, the code can be, and it can alert you if something happens and you need to be. Let's get into some common principles that exist in almost every language, including LSL. Just about every computer language you'll encounter, including LSL, has some very common concepts, structures, and principles. The individual styles vary slightly from language to language, but the way they function is almost always the same. Like I mentioned prior, all spoken languages have nouns, verbs, and adjectives that are used in different ways and structured in different ways depending on the specific language. In the same way, almost all computer languages have variables, functions, comparatives, and loops that are used in different ways. Let's start with variables. Variables exist in every computer language. They're just placeholders you can use to hold values, and that value changes as the code runs. For example, if you're selling clothes from a vendor, you may use a variable to keep track of how many you've sold. In contrast, all languages also have constants, which are variables that never change their value. Pi is a constant, for example, that holds the mathematical value of pi and never changes. Most languages, including LSL, have a variety of types of variables too. Numbers, for example, are different than words. You can't do long division with a sentence. By the same token, if you put numbers side by side in a sentence, it doesn't add them together in a mathematical equation. In computer code, in general, variables can only be combined and compared with variables of their same type. You can usually convert variables to other types if you need to. Like if you had a number style variable holding the numerical value 3, you could convert that to a text variable and then use it in a sentence to say we have 3 left in inventory. If you sold one, you would then subtract 1 from that number variable and then convert it to a string variable again, so you could say we have 2 left in inventory now. We'll talk about the type of variables in LSL in the next video. They have some unique ones. Just understand conceptually that variables are placeholders that hold a specific value that might change as the code runs. Another common tool used in every computer language are comparatives. In simplest terms, these are routines used to compare a value or values against another value or values, and then take action if a match is found, or maybe if no match is found. They're basically if-then checks that run in order. That's how most computer languages refer to them. For example, our code may need to evaluate what to do with the floor pedals in our car based on the color of the traffic light. If the light is green, we press the gas pedal. But if the light is red, we press the brake pedal. But if the light is yellow, we use caution. We probably need another comparative in the yellow section, in fact, to determine what caution is, right? If the light is yellow and we're more than 100 feet away from the intersection, hit the brake pedal. Otherwise, floor it. We'll get into the actual use and actual syntax of comparatives used in LSL later. For now, just make sure you understand what they do basically. Next, I want to talk about functions, another very common tool used in just about every computer language. These help you avoid duplicates and repeat, and thus help you avoid errors when you have to replicate something across multiple places in code. Remember our TV dinner example from before? Once we get the TV dinner on the counter, we have to decide whether or not to cut a slit into it, or whether or not to remove the plastic, or whether or not to do anything. We're going to use a comparative to make that determination. But imagine if we had to do that with every TV dinner in there. We would have to repeat that comparative sequence every time for every TV dinner so it would know the instructions. So instead of doing that, we use a function. We send the value of the TV dinner to the function, and we let the function make the decision on how we prep it. It can then return those instructions back to the original place in the code. So if I send the function a beef dinner, it's going to send me back the prep instructions for a beef dinner. If I send the function a turkey dinner, it's going to send back the instructions for a turkey dinner, etc. The big advantage is that you only need to write the function one place in the code and then just refer to it everywhere else you need to. This means if you have to change something about the function, you only have to change it here and not everywhere else in the code as if you had to do so for every TV dinner on the list. Variables offer the same flexibility advantage. If your code uses the value 4.816 1,000 times in the code and you have to change that value, you have to change it 1,000 times in the code. But if you create a variable for 4.0816, all you have to do is change the value of the variable and then just make sure everywhere you're referring to 4.0816 in the code, you just refer to the variable instead. Lastly, I want to talk about the concept of loops in writing code. A loop, just like it sounds, is a way of looping through everything in a list or a group and doing a comparative against everything in the list or group and maybe taking an action against everything in the list or group. All within a single sequence that just loops through everything in the list or group until you reach the end of the list or group. Like in our search freezer function in the TV dinner example. The function's going to loop through everything in the freezer until it finds the TV dinner we're looking for and then exit the loop. Loops are a great way to keep your code flexible and easy to manipulate, make it scalable and easy to change when you need to, and also keep it smaller. If some of the concepts I've talked about in this video are still a little blurry, just hang in there. You can always go back and refer to this video again if you need to better understand some of the concepts. You can also ask me a question in the comments if you need to. I'm glad to help if I can. In the next video, we're going to cover how things flow in LSL. We'll also give you some specifics on variables, comparatives, and loops in LSL, so you better understand those too. I have reference links in the description of this video for some of the things I've discussed here. If you have questions, again, make sure you let me know in the comments. If you like the video, make sure you click the like button, and I hope you subscribe, and I'll see you in the next video.